Yeah, hello. Yeah, I'm Nagesh Karmali. He's Sumanto, and she's Firuza. So we have open source EDA tools, and that is what we are working on. We have been doing that for quite some times. Um, let me ask Sumanto to introduce to open source EDA tools. So there is a desktop version, then there's a cloud version. I'll be speaking on the cloud version, and both of us will give a demo. Yeah, thank you.
Yeah, so hello everyone. So how many of you use electronic gadgets and all? Yes, so almost everyone. So we have smartphones, televisions, then tablets, laptops, and many things. Each of them have integrated circuits built in inside them, and this integrated circuit manufacturing is a very long process and very complicated process. So we have come up with so open source EDA. EDA stands for Electronic Design Automation. So we have come up with some open source tools to design these integrated chips. So as we can see the first point in the slide, the proprietary softwares are very expensive. So we already have proprietary softwares, but it costs lakhs of rupees or dollars to buy them. And so then and also these softwares are not all the time very much perfect. And so also recently in the COVID times we have seen that there was a shortage of chip, and the automobile industry was shaken due to this, and there was a lot of supply demand problems. There was a problem in supply chain management. So all of this was due to the lack of yeah, supply of the integrated circuits. Like the major integrated circuit fabs are like TSMC, Intel and all, and these gave the PDKs, process design kits, which are not very, not freely available. So it's very difficult to get them. And also, as I have said earlier, that proprietary softwares are expensive. So from training perspective, it becomes very much difficult for us to train people using these softwares. So simple students and all cannot buy this software. So this is a huge factor due to which India or developing countries is lagging behind in this manufacture of ICs. So and also the time to build and without damaging the hardware. So this software used to automate the process and the time. So if we do it manually, connect the wires and all, then fabricate it, then test it, every time it will fail and it will cost a huge amount of money. So we need the this software. Then and then there is we have the Make in India initiative by our Prime Minister, and recently we had about 76,000 crores of the budget have been dedicated to this Indian semiconductor mission. So to promote this, the development of this software in India itself, development of this integrated circuit in India itself. Now, this fabrication of this integrated circuits and electronic devices needs a lot of skilled engineers. So training them is a very huge factor to bridge this supply-demand gap. And we, FOSSEE, IIT Bombay, have taken initiative to develop this eSim desktop version and the eSim on cloud and Arduino on cloud. So I will go to the next slide. So first of all, I will talk on eSim desktop version, and Nagesh and Firuza will talk on the cloud version. So the eSim version is developed by FOSSEE team at IIT Bombay, and it is an EDA tool for circuit design, simulation, analysis, and PCB designing. So it is developed by integrating many other open source softwares, like there is something called as KiCad, used for schematic designing and all. And ngSpice, so ngSpice is related to something called as SPICE simulation, which is for electronic circuit simulation. Validator. How many of you have heard of this HDL programming, hardware description language? Yes, so you may be aware of the Verilog. So this Validator is a Verilog simulator. Now, similarly, there is also an open source tool called as MakerChip. It is a web IDE, so one can run the Verilog or a transaction level Verilog, a higher version of Verilog, in the web ID and check the synthesis waveforms and all. Then we have the tool called as GHDL. So this is also a HDL simulator, and it compiles the Verilog VHDL code. Sorry. And this tool is also built using integrating the Open Moudgalya software. So it is released under the GNU public license version 3.0. So moving on to the next slide. So features of eSim. First one is the schematic design, then the SPICE simulation, digital simulation using WebID, MakerChip WebID, then mixed signal simulation. So mixed signal simulation is a niche area and it's very much useful. It's achieved using this ngVary, like integrating SPICE with Verilator and ngHDL. So whatever smartphones, then television and all are this mixed signal area. And then PCB designing. So how many of you have worked on PCBs, made PCB in your college life, school life? Yes, so this you may be aware of, like it's a very interesting field. And then device modeling. So we can even model the discrete level devices using eSim. Then sub-circuit designing. So we can even develop the analog integrated circuits using eSim. And so it is supported by Ubuntu and Windows both. And we are also moving on for other OSs. And it is also interfaced with Open Moudgalya modeling software. And we have schematics converters, like from proprietary to eSim. Like in order to achieve this open source mission, one can simulate, if one has the schematics in proprietary software like PSpice or or freeware like LTSpice or some other, then they can convert it in eSim. So this is the eSim interface. So at the top, here you can see the schematic editor. Then this is a feature called as KeyCat to ngSpice, schematic to SPICE conversion, then simulation tab. Then this is the device modeling. And then we have the sub-circuit creation, MakerChip, and ngHDL, then Open Moudgalya interface, these two. Okay, so as you can see, the GUI is quite user interactive, and it's very much user friendly. So here is a circuit created in eSim. It's a mixed signal circuit. Used to decrement the PWM waveform. So I will show a promo video. Yes, so here we are creating a schematic and assigning the values to the components. So we are converting this schematic to SPICE analog. Then adding the simulation parameters, transient parameters. and we gave the waveform here. So it is developed by FOSSEE IIT Bombay, and this project is funded by National Mission on Education through ICT. Yeah, so I will go through the current activities under eSim, so which users can contribute to. So we have the circuit simulation project. It's a kind of a project. So the user can contribute this, run the simulations in eSim and give the upload the circuits in the website, and they will get a certificate and then recognition. Also, at times we give honorarium. So we also have this lab migration project. Similar to the circuit simulation project, whatever already available labs are there in other proprietary software, those can be converted to eSim, and the contributor gets a certificate and recognition. So we have 8 institutional labs to open source, and in the circuit simulation also we have 300 plus verified circuits throughout the country. So we have the eSim marathon. So the last marathon was conducted. It's a nation or practically worldwide competition. So we had VHD and Google in our last eSim marathon, and in last to last marathon we also had a company called as Redwood EDA. So all the people from throughout the nation come, collaborate, then contribute, and at last the winners are divided into various categories like outstanding, excellent, very good, good, and if we have funds, we also give the honorarium to the these winners. So I will go through this website once. Yeah, so this is the eSim website. So here we have the marathon completed circuits. So you can see the variety of circuits available here. Okay. So under this we have the participant name, then name of the college or institute from where he begins, he or she works, and then the circuit name, and we also have the link to the GitHub repository. So similarly, we had 3 marathons, and maybe some more maybe coming in upcoming months. So I will also quickly go through the circuit simulation project. So here is the procedure to submit you can go through it afterwards, and we have the completed circuits list here. So as you can see, there are 319 circuits as of now. We also have completed PSpice to KiCad circuits and LTSpice to KiCad circuits. So we have this textbook companion where it's not currently accepting proposals. However, we have some of the completed books. So the contributor takes a reference book, electronic or electrical reference book, and then converts it, like does the simulation in eSim. And then we have the lab migration. So as I've said, it's to convert the labs from proprietary to this open source eSim. And we are also coming up with a new thing called as electronic project development. So EPD, so we will be eSim project development. So basically we will be adding the, so the contributors can even contribute to the development of that eSim, and they will get a recognition. So yeah, also we have the spoken tutorial videos that Professor Kannan has demonstrated earlier on eSim. So yeah, in order to contact us, you can visit, you can mail us here at contactesim@fossee.in, and we have a Slack channel also here, and you can report the bugs, issues, feedback, and all on the GitHub page on this link. We also have a forum where you can discuss the various doubts. Yes, so here we have the statistics, some details of the marathon, who all were the partners and all. I will quickly, so you can have a look at this. Then, yeah, we also conduct fellowships and internships. So we had a winter internship. This is basically a development activity only. Most of them work on the development. Also, there are people who work on circuit simulation. And we also conduct workshops and conferences throughout the, at various places. Sometimes at here at IITB, sometimes at other places. And also, sometimes they are free of cost or sometimes they are paid. So let's move on to the cloud version. Nagesh sir will do.
Thanks, Sumanto. Thanks, Sumanto. So what you saw presently was mostly a desktop-based version. Okay. So desktop-based versions are generally you run it on your machine, and then sometimes they are buggy, and you have to port it on multiple machines or OSs, and you have lots of problems, right? So you need somebody to install, right? So what we did, we said we want to come up with a system where we can, have it a web-based, right? Should run somewhere on the cloud, okay? So maybe 50,000 users at a time, they should be able to do something, right? Rather than just one person. And then every time the same user is going to install something new, features every time, upgrades and all this stuff. So why not a web-based, right? I mean, so I've been using open source for the last 25 years. Okay, so I never used Windows, only 3.11, which was very old. So all of these components, in the system, they are all in open source. Okay, so whatever he has mentioned, they are ngSpice. So we use the same ngSpice. Okay, it's a highly matured product. Even the companies who have built a proprietary spice simulators, they use ngSpice inside. Okay, and then so ngSpice is highly matured product. Okay, so what we did, okay, I'll just quickly go through what we can do. We can drag and drop, right, components. There's an editor there. There's a schematic editor. That's what you would need when you want to draw wires between two components, right? Make a circuit, and then you would want to simulate it, right? So make a circuit. When you say make a circuit, it's a graph, right? If you are from computer science, I'm from computer science. Okay, I apply in other areas. So it's a graph. Can anybody tell me what is a node and an edge? Sorry? Is a component a node, right? Or edge? Oh, it's just the opposite. Because the component is an edge with a value. Edge with a value. And where you actually join is a node. So that's how you represent it. Okay, I'll show you. I'll show a demo. During that time, maybe you'll come to know. So, analog circuit simulation. Okay, started with analog circuit simulation, and then we want to move towards mixed mode simulations and other things. We need to have this sub-circuitry. What is that? 5 more minutes. Okay, I'll do it very fast. Yeah, so we have general components, and there's a simulator, and there's a ERC check. I hope ERC is something, it's a rule check which you do. And then there are solvers, right? So every simulation needs a solver, right? I mean, if you want to perform simulation, transient analysis or AC analysis. And then we have, if you heard, have you heard, is there a system which can grade electronic circuits? I heard of HackerRank and CodeChef, which can grade only computer science programs. So we have a system which can grade electronic circuits. Okay, so we'll show you a demo also. in 5 minutes. Okay, this is how it looks. Okay, there are all components on the site. You can pull, you can drag, you can draw, and then we put in some models inside. So there is an LTS support. So what we have done is I can embed this application right inside LMS's Moodle or OpenEdX or Blackboard, Canvas, and the student will actually perform, connect, various components based on the, the problem statement, and then the student will submit. Okay, it will go to our system, we'll calculate the grade, and we send it back to Moodle. Okay, this is how our system will look like. And so we have two systems. Okay, one eSim and Arduino on cloud, right? So Arduino on cloud, we have almost similar interface. You can see on the left-hand side, and then you have something to draw. Connect them, and then code. You compile it, okay, and then something. And you can also put it on the LMS. And we'll show a demo, not 10 minutes, 3 minutes. Okay. So unfortunately, our cloud, actually, we have hosted it on our cloud. I don't know, it's down presently, so we are giving it locally. It happens sometimes when you give a demo. Things don't work. Okay.
Can we sell FOSS?
Sorry?
Can we sell FOSS?
Yes, it's free, open source. It's running on localhost, yeah, presently, yeah. Okay, so this circuit, no, wait. Sorry. So this circuit, I'll show you, 2 minutes, okay. I'll show you, this is a graph, okay, this is generated. We generate this graph in the front end, okay. And, okay, fine, no problem. And then now I need to simulate, so I have to enter those parameters. Right, some parameters, but I should know what to enter if I'm aware of, or if I'm from that area. So I'll enter some parameters, right? And then I will say, simulate. Okay. So I'll get some output. Okay. User will get. So the user, the user interface is not very good. Okay. So I could have done it in a much better way. I could have shown a window somewhere else and things like that. Now I'll show you the netlist again. Okay. Those control parameters got added, right? Now, the overall functionality is something like this. This file is generated. This is ngSpice compatible. It will go at the back end, right? It will throw out some results. We interpret in the front end, and then we display those results. Okay. So, due to the constraint of time, I think less than 2 minutes left. So I'll just go to Arduino on cloud. We have something like, I'll show you something simple one. If you have time, maybe you can discuss with us later. I'll show you there's a, there's an code. So there's a code the student has to write, or somebody, the user has to write. This is a circuit, and now I'm going to simulate it. This pad is not very good. We can show this, yeah, you can see this. I'll tell you why this is important, but presently it is, you just have to. So this is how you can simulate. So there is visual, there is something which can rotate, okay, something which can sense gas, okay, something which can check the distance, okay, so this kind of simulations are there, something which can sound, it can actually play music. Okay, and you know how it is working. This is a front-end simulator. This is also a simulator. Every component is a simulator. The code which a student writes goes at the back end, converts it into a hex file by Arduino CLI compiler. The hex file is now interpreted in the front end, and appropriate signals are sent And this guy is listening to those signals, and based on that, it is going to display. Okay? So highly distributed. Yeah. So now we'll go for a small demo, if you allow. A very small demo. Okay. So we'll show you how you can put it on Moodle.
So you can, yeah, any professors. So any LMS which has a capability of embedding, using LTI support, that is Learning Tools Interoperability, can use our system and embed our circuits into the LMS. Let me just save this circuit. Thereafter, let me simulate it, because, so for example, what happens when a teacher wants to give out the circuit to a student? The teacher will draw the model circuit, as we have in a programming course. There is a model, and then you give an incomplete code, so incomplete circuit to a student. So let's just do that. First, I'll just simulate it. So what you see over here, these are zeros and these are ones. So at this particular point, what is the value of D7, 0, 1, all those things are getting displayed over here as a waveform. Let's just save it.
And these are our test cases. Okay.
Now let's say that a teacher wants to give an incomplete circuit. So I am removing this particular wire. And I will save the circuit again.
Partial grading is possible.
Now let me create an LTI app. So LTI app is nothing but I want a way of communication between my system and an LMS. So to communicate, we need to give some consumer key, a secret key, the score, and over here on the left hand side we would see the model circuit, and on the right hand side the student circuit. So let me select the student circuit and let me select the teacher circuit. So if you see over here, one wire was removed. We need to accept submissions from the user. There are some test cases which we generated while simulation. You can also have partial marking for circuit and for code. Suppose you don't want the student to concentrate on the circuit at all, you can give 100% weightage to the code and so on. Show code will actually display the code to the user, display the code of the teacher to the user. If we do not want that, so we'll just let it remain like this without selecting. Once we do that, we get an URL. On an LMS, I am logged in as a teacher. Sorry, the sandbox restarted. So I have logged in.
So Moodle sandbox, which you can use.
I hope that 4.1 versioning is your internal version, not the Moodle version.
Oh, no.
So now I'm setting it up over here. Let's say I write my title as 7 segment. I'll paste the URL that I had. Let me just give a name. Then the consumer key that we wrote on our system, the secret key, and then I'll click save. And then I'll click save and display. So the circuit.
It worked.
So the circuit is now embedded on Moodle. Now if I log in as a student, I'm logging out as a teacher, I'll log in as a student. So I'll go to the course and I can see that a teacher has created an assignment for me. There would be some description, of course. And now let's say I do not draw the wire. I go over here, the code is empty, so my task is to write the code and to draw a wire. Let me just only write the code so that I get some partial mark, hopefully. And I'll simulate it. Sorry.
Waveforms.
Yeah.
By the way, the student has to display the waveform so that.
So let's say some waveforms are being generated. If you see 4 displayed correctly, 5 is not getting displayed, 6 is okay, 7 is not okay, and so on.
And data points.
Yeah, the data
based
points
on
are being generated.
important.
So the grading happens based on the data points. Now let's say I click save. And now I want to submit the circuit which I just created. So over here, I get to see the data points that I saved. I click submit. And it says your score 0.91. That is because I did not draw the missing wire which I was supposed to. So I click OK. I can even, now I can see over here as a teacher, I go here, I get a submission which was made from this particular URL and the score. I can, as a teacher, can open the submission, see what the student has submitted, and so on. As a student on Moodle, I get to see my grade as well. So if I go to grades, I'll get to see that I scored 91 marks. Since 100 marks were given to this particular assignment, I got 91 marks because I scored 0.91. Yeah, thank you so much.
Thank you. Last half a minute. Half a minute. Just half a minute. Yeah. I don't know why IIT always has hotspot logins.
So how you
Yeah.
can?
Okay.
What?
I'll skip this maybe for somebody else. This is the architecture. I'm just going very fast. Okay. This is the current architecture. There are all the tools that we are using, all in open source. You can contribute, you have domain expertise, you can join research, product designing, performance engineering, system architecting, testing automation, right? Coding, developing, software engineering, process, and also technical writing. Anybody can join, see? Okay, why work in this project? Open source and all of those things. And then you can also use this product while teaching a course, maybe. You can see the design. Apply design patterns, make the software better, right? And do a lot of other things, even for writing research, enhancement proposals and other things. Long-term future goals, not only, why only electronic circuits? Why not mechanical, chemical, there are so many, which Professor Kannan mentioned, I think. So we can still think about building systems for, diverse applications. Yeah. And this is our link. Thank you.
So the first prototype was ready during the COVID time in 1.5 months by 6 interns of second year and third year colleges.
Wow.